So now that you've got a taste of the architecture and the concepts and kind of the key interfaces that are part of the executor service, let's begin our discussion of some of its key methods. And there's a lot of methods in the executor service interface, so we're not going to cover them all in one fell swoop. We'll start by looking at the ones that submit one or more tasks for asynchronous execution. So I think I mentioned before, the executor service extends executor and it executes tasks, so you can execute stuff and you can submit stuff. As we've seen, the execute method is just what you get with the executor interface, so we won't say much about that. It's not very useful because of all the limitations that you get with the one-way calls and so on and so forth. Much more useful is submit. And submit can be used to run two-way async tasks whose call hook method, so you can see callable has a call hook method, that returns a value. And this method is in fact very useful and very commonly used in practice. Now, what comes back from submit, unlike execute, which that returns no parameters at all because it's a one-way async call, submit, since it's a two-way async call, returns a future. And that future can then be used to control the lifecycle of the task that's running asynchronously. And this supports what we know as the synchronous future processing model. And so the way that this works is you submit stuff to the executor service, and then typically you submit a bunch of tasks that are running asynchronously. And then at some point you're like, I guess I really got to get those results. And so what you'll do is you'll have either the same thread, the one that started the wheels in motion in the first place, or some other thread will then go ahead and wait for, or call get, to wait for all the different futures that you have submitted tasks for. And so you kind of wait there synchronously to get the results of those futures. That's what's called the synchronous future processing model. There's another model called the asynchronous future processing model, and we'll talk about that later, certainly not today. So that's one model. You imagine a bunch of people who drop their clothes off at a dry cleaning service, and you don't just sit there waiting for your clothes. And then the dry cleaner says, come back in a couple of days. So the people come back in a couple of days, and then they wait and see whether their clothes have been finished. That's the synchronous future processing model. Note that future.get on the future return from submit can block, or will block, until a task completes successfully. So it's a blocking call. At that point, get returns the results of the task. Interestingly enough, you can also submit one-way async tasks that return no value. You can, however, do other things. You can cancel the computation. So you can say, I don't want to wait for this guy anymore. And that's something you cannot do if you use execute. You can't cancel something because you have no future upon which to cancel it. You can also execute groups of tasks. And these are methods called invoke all and invoke any. There's a couple different flavors of them. What you can do with these methods is you can pass in collections of tasks, and those tasks will be run all at the same time. And you'll see that there's a couple different variants here. By the way, if you pass in collections, don't modify the collections while invoke all or invoke any are running, because chaos and insanity will ensue. And that's because of the pass by reference nature of parameter passing in Java. If you're familiar with C++, most of C++ and the standard template library and other classes that are defined according to its principles do pass by value. But with Java, it's passed by reference. So you're passing a reference to something, and so if you modify it, then crazy things will happen. The invoke all method will return a list of futures it'll return a list of futures when all the tasks complete. This is a really bizarre semantic, by the way. So you call invoke all, and invoke all actually blocks all the tasks are run, and when it's done, it returns a list of futures. And so all the futures that are returned in this list are done. And you can they do this so you can figure out whether or not the tasks completed normally or exceptionally. So it gives you back a list of futures. Otherwise, you wouldn't know whether things had failed. If you just returned a list of values, you wouldn't know whether they failed. And invoke all waits for everything to finish. So basically, it's kind of group processing of stuff, and you get the results back when they're done. Invoke any, in contrast, returns the result of one successful completion. And obviously, it's going to be the one that finishes first, right? So this is useful for concurrent algorithms that just want the result that completes first. Let's say you're going to go search a bunch of repositories looking for the answer to something. Or you're going to compute, like which of these different chess moves will be the most likely to give you a good result. You don't want to wait for all of them. You just want to wait for whichever one finishes first, assuming you're playing that kind of chess. So invoke any will return the result when it finishes. It'll cancel all the other tasks that have not yet finished. So you'll only basically get one result and everything else is canceled. And all those other results are just ignored, whatever they happen to be. Now, as I said before, both of these methods block until they're done, either till everything is done or the first thing is done. And that can be very non-intuitive. When I first learned this, I was like, what the heck? Very complicated, very strange. And what you really want is something you get with the completable future framework, where you can get back a completable future to a list of completable futures, so you can wait till all those things are done asynchronously. But that's not the way that the executor service works. There's also parallel methods here, parallel being equivalent, not running in parallel, that have the same names, but they add timeouts. So you can do timeouts for invoke all. You can do timeouts for invoke any. Now, the semantics here are a little confusing. If the method did not time out, then each task completed. But if it did time out, some tasks may not or will not have completed. And so tasks that are not completed are canceled if the timeout occurs. Kind of a strange, not strange, it's just a complicated semantic. In this case, invoke any will throw a timeout exception if the timeout elapses, because we're not worrying about anything more than that one value. So that's the end of the overview of the first round of key methods in the Java executor service.